Welcome back to the real number system. In this video, we're going to talk about ratios and proportions. So let's get started. A ratio is a comparison of two quantities. For example, eggs may cost $1.75 per dozen. That's a ratio. Ratios can be written in several ways. First, you may see a ratio written in words, such as the ratio of A to B. Second, you may see it as A with a colon B, or last as A over B. Ratios can represent part to whole to part, or part to part comparisons. Let's suppose there are 7 males and 12 females in the Dewdrop Inn on a Monday evening. In the game room next door, there are 14 males and 24 females. Part A asks us to express the number of males to females at the inn as a ratio. Well, there are 7 males, use a colon for the ratio, and 12 females. This is a part to part ratio. Part B asks us to express the number of males to females at the game room as a ratio. There are 14 males, use a colon to represent the ratio, and 24 females. Our ratios need to be simplified just like we simplified fractions in a previous section. I'm going to write this as 14 over 24. This helps me to simplify my ratio. 2 goes into 14 7 times, and 2 goes into 24 12 times. And so my ratio is 7 to 12. This is also a part-to-part ratio. Now, look at Part C. Part C asks us to express the number of males in the game room to the number of people in the game room. So this would be a part to a whole. There were 14 males in the game room. 14 males plus 24 females gives us 38 total people. Again, always simplify your ratios. 2 goes into 14 7 times, and 2 goes into 38 19 times. And so our ratio would be 7 to 19. And as I mentioned, this is a part to whole ratio. Part D asks us to express the number of people in the inn to the number of females in the inn as a ratio. Well, all total in the inn, there were 7 males plus 12 females is 19 people over 12 females. And so our ratio is 19 to 12. This one is an example of a whole to part comparison. A proportion is a statement that two ratios are equal. If we have real numbers A, B, C, and D, where B and D are non-zero, our proportion A over B equals C over D is true if and only if A times D, the top of the first ratio, times the bottom of the second one, equals B times C. In other words, the bottom of the first ratio times the top of the second ratio. These are our cross products. Let's suppose that Allie and Binti type at the same speed. Allie started typing first. When Allie had typed 8 pages, Binti had typed 4. When Binti has typed 10 pages, how many pages has Allie typed? Now notice here, Allie and Binti are typing at the same speed. This tells us that we have an additive relationship. Binti typed 4 pages, Allie typed 8 pages or 4 more pages. So when Binti has typed 10 pages, they're typing at the same speed, so Allie will again have typed 4 more pages, and 10 plus 4 is 14. Let's look at another situation. Suppose Carl can type 8 pages for every 4 pages that Dan can type. Now notice here that Carl is typing twice as fast as Dan types. This is a multiplicative relationship. If Dan has typed 12 pages, how many pages has Carl typed? Well, Carl types twice as fast as Dan, so he can type twice as many pages. And 12 times 2 is 24. So Carl has typed 24 pages. Because of our multiplicative relationship in this example, we could also use a proportion to solve this problem. So Carl typed 8 pages and Dan typed 4 pages. So we have our first ratio, 8 pages of Carl for every 4 pages of Dan. A proportion says two ratios are equal, so equals. We know that Dan types 12 pages. Now we wrote the number of pages that Dan typed in the bottom of the first ratio. So I'm going to write the number of pages that Dan typed in the bottom of the second ratio as well. So the 12 pages goes in the bottom of the second ratio. We want to know how many pages Carl has typed, so that goes on the top of the second ratio. Notice that the number of pages that Carl types is in the top of both ratios, and the number of pages that Dan types is in the bottom of both ratios. We can use cross products to solve this proportion. 8 times 12 equals 4 times x. 8 times 12 is 96. Then divide both sides by 4, and we get that x is 24. This tells us that Carl can type 24 pages when Dan has typed 12 pages. Let's look at another example. If there are 3 cars for every 8 students at a high school, how many cars are there for 1,200 students? So we have our first ratio, 3 cars for every 8 students. Set up a proportion, so equals, and we want to know how many cars there are for 1,200 students. Since 8 students is in the bottom of the first ratio, the 1,200 students goes in the bottom of the second ratio, and the number of cars goes on the top of the second ratio because the number of cars is on top of the first ratio. So notice that my matching pieces are in the same places. The number of cars is in the top of both ratios, and the number of students is in the bottom of both ratios. Use your cross products to solve. 3 times 1,200 equals 8 times x. 3 times 1,200 is 3,600. Use your scratch paper and divide both sides by 8, and so we get 450 for x. That tells us there are 450 cars. If two variables x and y are related by equality, y equals k times x, then we say that y is proportional to x, and k is what we call the constant of proportionality. Now the idea behind our proportions is this. The ratio of one quantity to another remains unchanged even as the numerical values of both of our quantities change. So let's suppose a car rental company charges $20 for one day and $40 for 2 days. Is time proportional to cost? If time is proportional to cost, for every situation we can write time equals k times cost, and k will be the same in every situation. Our first situation is $20 for one day. So our time is 1 equals k, and our cost is 20. Divide both sides by 20, and we get that k is 1 over 20. Now let's look at our second situation. We have $40 for 2 days. So our time is 2 equals k, and our cost is 40. Divide both sides by 40, and k is 2 over 40. Simplify that fraction. 2 goes into itself 1 time and into 20 times. And so that gives us k equals 1 over 20. Notice that k is the same in both situations. So yes, time is proportional to cost because the ratio of time to cost stays the same when both time and cost change. In part B, we're asked for the constant of proportionality, and that constant of proportionality is 1 over 20. Well, can I also say that cost is proportional to time? If so, then cost equals K times time, and K will be the same in every situation. Our first situation, we have $20 for one day, so the cost is 20 equals K times 1 is our time one day. So K is 20. For our second situation, we have $40 for 2 days. So 40 is the cost equals K, and the time is 2. Divide both sides by 2, and we get that K is 20. Notice that K is the same for both situations. So yes, cost is proportional to time because the ratio of cost to time stays the same even when both cost and time change. And our constant of proportionality here is 20. Let's look at some other strategies. Another strategy for proportions is our scaling strategy. This strategy uses the LCM to find a common number for both situations. In example 6, we have 12 tickets for $15 or 20 tickets for $23, and we want to know which is the better buy. Let's use the scaling strategy to answer the question. So first, I find the least common multiple for the number of tickets. So the least common multiple of 12 and 20. One easy way to find the LCM is to start with your bigger number, which is 20. 12 does not divide 20, so 20 is not the LCM. The next multiple of 20 is 40. 12 does not divide 40, so 40 is not the LCM. The next multiple of 20 is 60, and 12 divides 60. Since both 12 and 20 divide 60, 60 is the LCM. Now, I want to look at both of my situations, 12 tickets for $15 and 20 tickets for $23. And I want to see in each situation how much 60 tickets would cost. So I'm going to set up two different proportions. So here's my second step. I have 12 tickets for $15. I want to know how much 60 tickets is going to cost. So I have 60 tickets on top and X for my cost on bottom. Notice again in my proportion, tickets are on the top in both of my ratios on both sides, and the cost is in the bottom on both sides. Use cross products to solve. 12 times X equals 15 times 60. 15 times 60 is 900. Divide both sides by 12. I used my scratch paper and I got that X is 75. So 60 tickets would cost $75. Another way you could solve this proportion is this. 12 times 5 would make 60 on top, so 15 times 5 would make 75 on the bottom. My third step is to look at that last situation and set up a proportion. 20 tickets for $23, and I want to know how much 60 tickets cost. Notice again, in setting up the proportion, the tickets is on top on both sides, and the cost is in the bottom of both sides. Use your cross products. 20 times X equals 23 times 60. 23 times 60 is 1,380. Divide both sides by 20, and I used my scratch paper and got $69. Well, this is cheaper. So this tells me that 20 tickets for $23 is the better buy. A second strategy for proportions is the unit rate strategy. Here we find the rate for 1 unit. So let's look at this same problem that we looked at in example 6, but this time we're going to use the unit rate strategy to determine which is the better buy. 12 tickets for $15 or 20 tickets for $23. To figure out the unit rate, that means I want to know how much one ticket will cost. Divide 12 into 15. 12 goes into 15 one time with 3 left. Now, because I'm dealing with money, I want to think about my dollars and cents, so I'm going to have my decimal place. My decimal place is understood to be behind the 15, and there's understood to be a 0 there as well. If you include your decimal place under the division symbol, your decimal place goes in the same position in the quotient. Bring down your 0. 12 goes into 30 2 times, and we're left with 6. Because I have a remainder, I'm going to keep dividing. Write another 0. There's understood to be another 0 there, and bring that 0 down. 12 goes into 65 times, and now I have no remainder. This tells me that one ticket will cost $1.25. Well, let's look at how much one ticket will cost when I buy 20 tickets for $23. So divide 20 into 23. 20 goes into 23 one time, and there are 3 left. Again, because I'm dealing with money, I want to think about my dollars and cents. My decimal place is understood to be behind the 3, and I'm understood to have a 0 there as well. When we include the decimal place under the division symbol, we also include it in the same position in the quotient. Bring down your 0. 20 goes into 30 one time with 10 left. I have a remainder, so I'm going to keep dividing. We are understood to have another 0 at the end and bring that 0 down. 20 goes into 100 5 times, and now we're left with 0. That tells me that one ticket would cost $1.15. This is the better buy. So 20 tickets for $23 is the better buy. Let's look at another example. Kai, Paulus, and Judy made $2,520 for painting a house. Kai worked 30 hours, Paulus worked 50 hours, and Judy worked 60 hours. They divided the money in proportion to the number of hours they worked. If they all earned the same rate of pay, how much did they each earn? So notice here, they all earned the same rate of pay. My first step is to figure out how many hours total they all worked. So I add 30, 50, and 60, which gives me 140 hours. Then I need to find the unit rate. So in other words, how much did they get paid for each hour? I divide 140, the total number of hours, into 2,520, the total pay. 140 goes into 2,520 18 times. So the rate of pay is $18 per hour. My last step is to find how much they each make. So for Kai, I multiply $18 per hour times 30 hours. That tells me he makes $540. For Paulus, $18 per hour times 50 hours is $900 that Paulus earns. And for Judy, $18 per hour times 60 hours tells me that she earns $1,080. A third model that we have is the bar model. Let's suppose that the ratio of 8th graders to 7th graders at a meeting is 4 to 7. 1/4 of the 8th graders are boys, and 2/7 of the 7th graders are boys. What is the ratio of boys to students at the meeting? I'm going to begin by thinking about the ratio of 8th graders to 7th graders, so 4 to 7. I'm going to draw 4 blocks to represent the 8th graders. Then 7 blocks to represent the 7th graders, because our ratio was 4 8th graders to 7 7th graders. So 4 blocks and 7 blocks. Part A tells us that 1/4 of the 8th graders are boys. So of those 4 blocks for the 8th graders, I'm going to shade one of those blocks, 1 out of 4. Then 2/7 of the 7th graders were boys. I have 7 blocks for the 7th graders and shade 2 of those to represent the boys. So 2 out of 7 blocks for the 7th graders are shaded. Notice I have 3 blocks shaded to represent the boys. There are a total of 11 blocks, and so my ratio here is 3 to 11. Now let's suppose there are 9 boys at the meeting, and we want to know what's the total number of students. Well, 3 blocks represented the 9 boys, or those 9 students. We have a total of 11 blocks, and I want to know how many students the 11 blocks represented. Notice in my proportion, I put the blocks on top on both sides and the students on bottom on both sides. Your matching pieces need to go in the same places. Use your cross products. 3 times x equals 9 times 11. 9 times 11 is 99. Divide both sides by 3 and we get 33. So there are 33 students at the meeting. Let's look at another example. Arnold, Barbara, and Caleb have candies in the ratio of 4 to 5 to 7 respectively. So I'm going to start with Arnold, and I'm going to draw 4 blocks for Arnold. I'm going to draw 5 blocks for Barbara and 7 blocks for Caleb, 4 to 5 to 7. Next, the problem tells us that Caleb has 21 more candies than Arnold. Also notice that Caleb has 3 more blocks than Arnold. So those 3 blocks represent those 21 candies. I'm going to set up a proportion. 3 blocks represents the 21 candies. Now I want to know how much 1 block represents, and then that will help me know how many candies Arnold has, how many candies Barbara has, and how many candies Caleb has. So set up your proportion. Since we use the blocks on top in the first ratio, then the block goes on top in the second ratio. Remember, a proportion says 2 ratios are equal. And the candies goes on bottom in both ratios. Use cross products. 3 times x equals 21 times 1. 21 times 1 is 21. Divide both sides by 3, so x is 7 candies. In my third step, Arnold had 4 blocks times 7 candies, tells me he has 28 candies. For Barbara, we have 5 blocks. Each block represented 7 candies, so 5 times 7 is 35. And for Caleb, there were 7 blocks. Each block represents 7 candies, so 7 times 7 is 49. One important aspect of setting up a proportion is to be sure that you include the units of measurement, as I have in our examples so far. Suppose a turtle travels 5 inches for every 10 seconds. How many feet does the turtle travel in 50 seconds? So first, set up your proportion. We have 5 inches over 10 seconds. Now the turtle is traveling 50 seconds, and because seconds is on bottom on the left, seconds goes on bottom on the right. And I want to know how far the turtle travels, so that would be x. And because our units are inches on the left, our units on the right on the top is also inches. Use cross products to solve. 5 times 50 equals 10 times x. 5 times 50 is 250. Divide both sides by 10 and we get 25. Now remember here, our units were inches. But the problem asks us for feet. There are 12 inches in every foot, so I divide 12 into 25. 12 goes into 25 2 times with 1 left. That tells me that our turtle travels 2 1/12 feet. Here are a couple of other facts about our proportions. A over B equals C over D if and only if reciprocals are equal. Also, A over B equals C over D if and only if A over C equals B over D. One application of ratios and proportions is our scale drawings. The scale is the ratio of the size of the drawing to the size of the object. Suppose the main floor of a house in the figure drawn is in the scale of 1 to 300. Further, suppose you measure the living room with a ruler and find that it is 3 centimeters by 2 centimeters. And we want to find the dimensions in meters of the living room. Well, first, I'm going to label the living room. The longer side is the 3 centimeters in the drawing, and the shorter side would be the 2 centimeters. Notice that the problem asked me for the dimensions in meters. So let's think about meters and centimeters. I know that 1 meter is 100 centimeters. Now I'm going to think about my ratio, 1 to 300. So the 1 is 1 centimeter, and the 300 is 300 centimeters. Let's change 300 centimeters to meters. So I divide 100 centimeters into 300 centimeters. That gives me 3 or 3 meters. And now my ratio is 1 centimeter to 3 meters. Let's start with the long side of the living room. We have 1 centimeter to 3 meters equals 3 centimeters to x meters. Notice again, centimeters is on top on both sides and meters is on bottom on both sides. Use your cross products. We have 1 times x equals 3 times 3. And so we have x equals 9 or 9 meters. Let's look at the short side. So I have 1 centimeter is to 3 meters. The short side is 2 centimeters, and I want to know how many meters it is, so that would be x. Again, notice the centimeters is on top in both ratios, and the meters is on bottom. Use your cross products. 1 times x equals 3 times 2. So x equals 6 or 6 meters. That tells me that the living room is 9 meters by 6 meters.